participants, ma'am, all the participants are faculty from the different institutions
Okay.
across the country. So
Okay.
all are
Thank you, sir.
faculty.
Okay. I hope my screen is visible.
Yes, ma'am. Yes, ma'am.
Okay, I'll
Yes,
put
ma'am.
it onto the slideshow mode. So is my first screen, is my first slide visible? That is into the slideshow mode.
Yes, ma'am. Perfectly fine, ma'am.
Okay. Are my slides moving as well?
Yes, 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 ma'am.
Okay. Okay, I'll start. So a very good morning and a warm welcome to all the participants. And first, I would like to thank MNIT Jaipur and AICT Academy, especially for this particular course. I would like to thank the coordinators, Professor Surinder and Professor Rajesh, for holding this particular insightful regarding the course onto the machine learning. So today I'll be talking about something where I'll be starting from a journey towards the logistic regression, right? And then I'll be discussing what's the difference between the regression and the classification. I'll be taking you towards some of the use cases, where to use the linear regression and where not to use the linear regression, and how to switch on from the linear towards the logistic regression. Then I'll be demonstrating the logistic regression through Python, and I'll be giving a demonstration through Google Colab. I hope you'll enjoy the session. So if in case you have some certain doubts, you can stop me in between as well as you can ask at the end of the session as well. So here I'll start with, so basically all of you till date might have learned about all the sessions where you might have learned about the machine learning, and you had a simple idea of, okay, what's machine learning is being divided into a supervised learning, an unsupervised learning, or a reinforcement learning. So since you can see some certain images onto a supervised, unsupervised, and a reinforcement learning, I'll just simply reiterate that a very quick glance of it. Okay, there is always something as an instructor which always gives an instruction, and you are learning under the supervised learning. So unsupervised is something that, okay, you are being given some certain open book assignment and you don't have some certain instructor for that particular course, and then you have to learn about that particular course by yourself. So that is, for example, an unsupervised kind of a learning. And reinforcement learning is that you are, for example, you are being pushed onto some certain island, right? And you don't have any idea regarding the island, and then you were being told, okay, you have to survive into this particular island. So you got panic for a certain amount of time, and you think, oh, I was living into some certain conditions which were very favorable for me, and suddenly I have been shifted to this particular but then you learn how to survive into that particular environment, right? And you make yourself being adapt to what to eat onto that particular island, what not to eat onto that particular, which particular climate conditions are okay. So you learn by that particular situation. So that's an example of a reinforcement learning. So that's basically, now since we are talking about the logistic regression, so the thing is that the logistic regression comes under the supervised learning, question mark, it comes under the unsupervised learning, or it comes under the reinforcement learning. So that is what the basic question where we usually think of it, and then we try to answer to this particular question during this particular session. Now, under the supervised learning, so I should tell you that since we are talking about the logistic regression, it comes under the supervised learning. So under the supervised learning, first of all, the main categories being categorized as per the Andrews book is that we classify or we apply a regression. So now basically what's the difference between the classification and the regression? So consider an example that will it be hot or cold tomorrow? Right? Will it be hot or a cold tomorrow? Right? So if I consider it as simply a binary classification, I'll be considering either I'll be having the labels being assigned to it, or I'll be having the class. So here the class or a label can either be hot, or the next label can be cold. Right? So will it be hot or cold tomorrow? So I'm able to answer, okay, it may be hot, it may be cold, depending upon what the particular data set I'm having in hand. So I can classify it in either the class as the hot, or I can classify or label it as cold. So that's the classification where I'm talking about a binary classification. So in addition to the classification, apart from a binary classification, I may have a multi-class classification as well. Now, what's a regression? Right. So regression is basically a predictive kind of a technique, right? That says that, okay, based on the previous data set trends, right, what is likely to be happening, what is likely to be predicted. So what will be the temperature tomorrow, right? So we, for example, we see the trend of the last week or the last month, and depending upon that, we are able to give a certain suggestion that, okay, the temperature tomorrow will be something 84 degrees Celsius or 84 degree Fahrenheit, depending upon what we have into the past month, if we are collecting a data for past month, or if in case we are collecting a data of a last week. So that's basically the difference between the regression and the classification. Now moving further, so this is what I was talking about. The regression can further be classified as the linear regression. It can further be classified as the logistic regression. It can be a polynomial regression. It can be a multivariate regression as well. So under the classification, I can classify it either as a binary, in which I already gave an example of. Either you can classify it as a hot, you can classify it as a cold. And similarly, you can take another example where you have an emails and you can classify them either as a spam, or you can classify them either as a non-spam, right? So based upon that, that's the example of the classification. And into the regression, if I consider two things, one is onto an x-axis and another one is onto the y-axis. So by the time now, you might have been aware of, okay, what's dependent variable and what's an independent variable. So one variable will be, if I consider a 2D graph, on one axis I'll be considering a dependent variable, on another axis I'll be considering an independent variable, and trying to find the relationship between the dependent variable and the independent variable will be something that will be covering under the regression part. So what basically a regression is? So regression analysis, as per to the best of my knowledge, is a predictive modeling technique. So if I come to towards the statistics, so statistics says that it's a model to find the relation between a dependent variable and an independent variable. But it's not that the independent variable can only be one. There can be more than one independent variables as well, right? So to find out the relationship between a dependent variable and one or more independent variables is what we mean by the regression. So for example, in the figure, you might see that there is something being shown as a linear regression and there is another thing being shown as a logistic regression. So I'll first, since you have already covered the lecture onto the linear regression, but I'll simply give you a glance of the linear regression and then taking you a way forward towards the logistic regression. So I'll start with the linear regression. So the linear regression says you have something as a continuous points, right? And for example, consider this equation as y is equal to mx plus c, where m is the slope and c is the constant. For example, consider this simple line equation, and I say y is equal to mx plus c. So the linear regression says that there is a continuous points that are revolving around this particular point, around this particular line, and you try to find it out the relationship between the dependent variable and the independent variable along this particular line. So the important thing to note here is that the data points are continuous. Okay, so how I differentiate that from the logistic regression is, in the logistic, if you see, we are shifting from a straight line towards a sigmoid kind of a function, right? So the sigmoid kind of a function, moving from the simple straight line function towards the sigmoid kind of a function, is something you have on this particular thing, you have 0, here you have 1. So you are just trying to give a binary kind of a value that either you classify it as 0 or you do it as 1, right? So logistic or logic regression is shifting from this particular continuous variables data points mapping onto this one towards categorical values, and that category is usually binary. Most of the times this categorical variables are usually binary, where this particular line denotes a 0 and this particular line denotes a 1. And then there is a sigmoid function which says that, okay, you are trying to make a move towards either this towards 0 or you are making a move. But how will you move from either, you will be categorizing it as a 0 or how you will be categorizing it as a 1 is an important point of concern. So what it says is that we usually take a threshold. We usually take a threshold, and if the value lies, if the data points are lying below that particular threshold, we'll be considering it as being mapped onto the categorical value 0. And if it is greater than the threshold, we'll be mapping it to the data points to this particular thing, which is referred to as 1. So the general use cases of the regression are determining the strength of the predictors. For example, if in case you want to find out the relationship between the age and income, right? So for that kind of an example, we can use a regression analysis. Then forecasting an event, right? For example, if we want to forecast, okay, what will be the temperature tomorrow? So for that kind of, and then the next is the trend forecasting. For example, I want to know the trend, okay, how much the price of the Bitcoin will increase into the next 6 months, right? So based upon the previous trends, I'll be able to figure it out. Okay, so that's the Bitcoin may raise to this particular value in the next 6 months. Now that's the about the mathematics behind the logistic regression. So while I was talking about the linear regression, I referred to a simple equation y is equal to mx plus c, where m was the slope and c was referred to as a constant. So the logistic regression or the logit regression says that I am a direct probability model, right? And the sigmoid function usually is being given as 1 is equal to 1 divided by 1 plus exponential of minus z. Now z here is what? Z here is the same y is equal to mx plus c that I was defining as. So, but what happens is, so the probability towards it has a probability towards 0 as the z tend towards the minus infinity, and as the z tend towards the plus infinity, the probability is towards the 1. So it says that let us consider an infinite minus infinity to infinity, and then it says that the probability usually is towards 1 as the z tend towards the plus infinity, and as the z tend towards the minus infinity, the probability tends towards the 0. And then there is a threshold which will be able to map. Now, what it says that this logistic regression will in actually be referred to as a classification algorithm, which is used when the dependent variables is binary or a categorical one. But what it says is, if I put the value of y into this particular place, at this particular place, right? So 1 plus 1 plus 1 divided by 1 plus e to the power of minus z. Now z here is y is equal to mx. So if I'll put it mx plus c, so it says it is used to put the value of, use the value of the linear regression. That is why it is referred to as the logistic regression, right? Although it helps us to do and solve the same classification algorithm, and it gives us similar result as that, but in actually why it is being referred to under the regression category is because it uses the mathematics of the linear regression, and then it gives us this particular equation for the logistic regression. So this is what I was talking about while I was talking about that the independent variable is being depicted onto the x-axis and the dependent variable is depicted onto the y-axis, and this is the straight line. And then if I shift from the linear regression towards the logistic regression, it's a sigmoid curve, S curve, and predicted value of the dependent variable y lies within the range of 0 and it lies within the range of 1. So the linear regression phase, usually whenever we have classification problems, and we often deal with the categorical outcomes and logistic regression models. The probability, as I've already shown you into the function onto the last slide, where I refer to as the probability function is equal to 1 plus 1 by 1 plus 1 divided by 1 plus exponential and then minus of z. So the decision making becomes easier using the probability thresholds. So that is why there was the need for shifting from the linear regression towards the logistic regression. Now, why the logistic regression? Why? Why? The answer to the why is, the first is because it's simple and interpretable, right? It's well suited for linearly separable data. It provides the probability estimates as well, and it handles the binary classification problems very effectively. So that is why we usually go with the logistic regression. So I'll tell you some certain use cases before I should differentiate between this one. If I'll consider this particular use case for the linear regression, and I'll also discuss a use case for the logistic regression, you'll be able to differentiate between the two. So for example, you have some certain number of rooms, and then you have the target value, right? So it says that, and here what we will do into the next lab session is, we have a radius mean and we have a target, and we just want we have a breast cancer data set, and we want to classify from the breast cancer data set that whether the person has the tumor belonging to benign or it's malignant. So that is what we'll be discussing into the next one. And here you have a different data set. For example, you have the number of the rooms and you have the target, where we want to know the house prices versus the number of the rooms, right? So depending upon that, I just want to have. So if you see, the average number of rooms is being shown over there into the x-axis, and the median value of the homes is shown onto the y-axis. So this is our independent variable and this is our dependent variable. So you can see that in case of a linear regression, where I'll be using a straight line and this one. So if you see these data points, so these data points are more or less for the continuous variable, right? So then you'll try to map it along this particular line. And in case of the logistic regression, you'll simply have two target values. One target value is a benign one and another target value is a malignant one. So you decide a threshold here, right? So the target can be a diagnosis. You either diagnose it as a benign or you either diagnose it as a malignant, depending upon, because the data set that we are considering into this particular case is a breast cancer data set, right? So you diagnose it either as 0 or you diagnose it either as 1, right? So here we had some certain threshold where, for example, I put the threshold as this one, and then it says the data points that are above this particular threshold are being classified under the malignant category, and those which are having a below the values of the threshold are being categorized under the 0 values, right? So that's the basically a sigmoid kind of a curve, and these are the data points that are mapping below the threshold and those that are mapping above the threshold. Now I'll compare the linear and the logistic regression based on some certain parameters. So the parameter first, the definition is to predict a continuous dependent variable based on the values of the independent variable. So here what you have to take into consideration is the word continuous, right? And here in the logistic regression, the main emphasis is on the categorical variable. So categorical here usually is a binary variable based on the value. So true, false, 0, 1, like something like this, based on the values of the independent variables. So the function used for the linear regression is a linear one, and the function used for the logistic regression is a sigmoid one. The output is a continuous type for the linear regression. The output in the logistic regression is a categorical, usually the binary, true, false, or 0, 1. The estimation type is one of the important thing that is to be taken into consideration, right? So here what it says is that it follows a least square estimation type, and into the logistic regression there is maximum likelihood estimation. So now the least square, since it's a least square estimation, the evaluation parameters will correspondingly be varying when I'll be using a linear regression, and since it's a maximum likelihood, the logistic regression will be correspondingly having those particular evaluation matrix for that one. So the use case here is to predict the values. The use case here is to classify basically. So the application domains can be the business domain. The application domain can be the forecasting, says for the linear regression. For the logistic regression, the application scenarios can be cybersecurity, image processing, and some of the classification problems, for example, can be the use case for the logistic regression. So first of all, what we usually do is when we work along with our BTech students and they simply take a course onto a machine learning, what they usually do is they simply apply all the algorithms, all the ML algorithms, make a table, right? Try to find out the accuracy, try to find out, okay, what is the precision recall, and then they say, okay, the BTech project is over and they have applied all the machine learning algorithms, but they haven't even tested that whether the precondition is being satisfied or not. Then if you ask what was the precondition and was the data set that you are having in hand is having that particular prerequisite, right? For example, despite of a logistic regression, if somebody applies an SVM or if somebody went for PCA, like, and or somebody went for some other particular ML algorithm, so like, was it fit? Because since we classified it as a under the supervised learning, right? So the supervised learning are going to behave differently. The unsupervised learning algorithms will behave differently. And of course, when you are being into a situation where you have a reinforcement learning, right, you have to behave differently, right? So since the basic core of that particular algorithm is the same, simply applying all the machine learning algorithms and giving an output and giving an accuracy is not a right thing we should do. So we should always learn, okay, what is the precondition that this particular algorithm of machine learning follows, and whether this particular algorithm, this particular technique should be applied or it should not be applied, right? So that's the first question mark before considering what data set you are having in hand and what is the output being expected from that particular data set, right? So I'm not saying that a single data set cannot be used for the two purposes. The single data set can also be used to compare various supervised learning techniques, but you have to make sure what is the output, what was the target, right, for the being expected from this particular input and what is the target being expected from this particular. So that is why based upon the application scenario, which usually we say that we want to forecast the sales and we want to say, okay, if I'll be spending this much amount onto my advertisement, right? So this is how much increase in the sale I'm expecting into the next 6 months. So depending upon that, I'll be spending, if I'm running a business, I'll be spending that much amount onto advertising. And if I see, okay, my sales is not going to increase based upon if I'll apply a linear regression and my sales is not going to increase, then of course I'll not be spending that much amount of cost onto the advertisement thing. So that is what it helps us to make a decision, a support, a decision making kind of a support is being provided. So that is why we usually apply the regression analysis. And similarly for an image processing kind of application scenario, we usually go along with the logistic regression. So this was a use case that I illustrated, and this is in actually what we'll be running into the today's lab session. So the data set which I'll be demonstrating will be picking it up from the Kaggle, and after picking that particular data set from the Kaggle onto the Python, I'll be telling you what are the various steps. So I'll simply elaborate, okay, what are the various steps. So before moving on to if there is some certain doubts regarding if in case you want to ask, okay, what's the linear and what's the logistic, I'm open to that. And then I'll illustrate, okay, these are the steps that you have to write down. Although nowadays, all the libraries are already available, right? All the libraries are already available. You pick up a software, right? And with the help of the LLMs, those can even write the code for you. Simply say, do this particular thing, the LLM will even, one of the best good LLM may give you a code for that particular thing also. But then moving into the words of the LLMs and not learning the basics of that particular thing is not a good point of concern. You should know the mathematics, you should know whether it should be applied, whether I'm applying the same thing, right thing onto the right data set, and I'm expecting the same output, then only you go ahead with that. Otherwise, I would not suggest to make use of an LLM-based model. So these are some of the use cases of the scenarios. So for example, I'll start with the Titanic data analysis. So under the Titanic data analysis, what happened at that particular moment of time, there was no much of analytics, there were no much of machine learning algorithms into place at the time when actually the incident happened. But nowadays, if we take a Titanic data analysis, we can very simply analyze, okay, what was the survival rate and which particular person has survived and which particular passenger has not survived, and what is the probability of survival of these particular uh, passengers if such a situation may happen. So the Titanic data analysis can be done making use of a regression analysis. Then predicting, so you can try it on. Since I'll be making you learn to work onto a breast cancer data set, you can have another data set. For example, you can pull up the data set of the Titanic, and then you can do an analysis, and then you can see, okay, how the trend is working. So predicting the presence of a disease, yes or no kind of a condition, right? So that's the use case scenario where you can see. Then the credit card default prediction and the employee attrition prediction. For example, you are getting so much of cost and you want to fire some certain employees, and then you want to take a decision regarding this one. So you can apply in logistic regression and you can have an employee attrition prediction based upon that. So any doubts before I move on to the steps that are being required to perform a logistic regression? Okay, so if there are no particular questions, I'll move further ahead with illustrating the steps that are being required to perform the logistic regression. So the step number 1 is your data collection part. Okay, and under the data collection part, you first have to, either the data should be given to you, right, or you think by yourself that you'll be considering this particular data set, and this particular data set is, and this is the output that is being required. So now the breast cancer data set has been picked up, and what our output, what our target is, we have a defined thing, right? And we have a defined thing that defined thing is usually referred to as a label. We either want to label it as a benign or we want to label it as a malignant, right? So that's what our output or the target variable is. So depending upon the parameters that are being given to us for the breast cancer data set. So first is the data collection part. So one is either you capture the data, right? For example, if you want to work onto an image processing classification, sometimes the image data related to that particular problem is not there, right? And then you have to collect the data, you have to take your camera and you have to do it by yourself. Or if the data set is already available, then it's very good. You have to simply load and you simply have to pre-process the data. Right. So now by data loading means that you have a CSV file, you uploaded it. Now what the word pre-processing means is that there may be some values that may be sparse. There may be some values that may be null, right? And there may be some values which are like maybe something like an outlier, right? For example, if I consider a normal blood pressure data, right? For example, the systolic and diastolic is there, right? So I say my blood pressure is 120 by 80 mm per Hg, right? And if the value that was being inputted and recorded was 320, right? Or 420, right? Since I know the normal range is 120 by 80, right? So it can go up to 200, it can go up to 250, but that's in a normal value. For example, do not even take it as 400, consider somebody entered as 1400, but I being aware of that particular value range, I cannot expect this systolic value to go beyond this particular value, and the value 1400 will be something called as an outlier. So you need to pre-process the data and you need to remove that particular value, since into a healthcare domain and every domain, the data is very crucial. So you need to pre-process the data. Otherwise, your machine learning algorithm will be training the based upon what data set. And there are some certain absurd values like this, for example, right? For example, I told 1400. So consider there may be something absurd like this one. So that is why we need to pre-process. We need to remove the outliers. We need to remove the null values, and we need to remove the sparseness into the data as well. So that's the pre-processing of the data. Now there's some certain methods for doing the pre-processing. For example, in an outlier case, you take the average of all the values, and then you substituted that particular value by an average value maybe. But it's not that compulsory that you pre-process it this way. You can have other, despite of an average, you can take a mean or something else, also depending upon what the use case was. Now, this moving on, when you loaded and when you pre-process the data, the step 2 is you define, since we are performing a logistic regression, so we'll define the sigmoid function and we'll define the loss function, right? So I'll come to it. Okay, what's the loss, the details of the loss function into the next session. And then the step number 3 will be, we define the gradient descent function to optimize the weights. And then we train the model, and finally we plot the decision boundary. So that's how you categorize it, as starting from the data collection, then moving on further, applying, defining a sigmoid function and a loss function, defining the gradient descent function to optimize that particular weights, then training the model, and finally plotting the decision boundary, where the plot will be something like this one, right? So you categorize it either as under the category of benign, or you categorize it under the category of malignant. Right. So this is, for example, the value, and this is the target being classified as benign or malignant. So if you see, the radius mean is 12.47, 18.93, 15.46, 12, then 11, then 20, then 22. So is there anyone who can, from this particular given value, can let me know, okay, this may be the threshold based upon which I classified them either as a benign, or I classified, making use of a logistic regression, I put it in under the category of a benign or a malignant. So I'll be able to get, okay, how much you are able to understand for what I spoke into the last 45 minutes. I'll be getting a simple idea. If you'll be able to just see the, analyze the data set, this value, see this column, right? And then simply think of above which particular threshold they will be classified as malignant, and below that particular threshold they will be classified as benign. So can I see into the chat box, or nobody would like to answer? Let me see if I'll be able to see it into the chat box. If you, okay, so above 15, okay, yes. If the value is less than 14, and if the value is above 15, yes, very correct. So there's an answer from Jyoti, and there's an answer from KS, some Sushma, and from Jyoti. Okay, thank you so much, Jyoti. Thank you so much, Sushma, for giving an answer to me. So I hope I made you clear this particular thing. Okay, so considering into the next hands-on, I'll be giving you this particular data set, and then we'll be learning the code into the Python. So I hope all of you have your Gmail accounts, and all of you can have a Google Colab account. So if in case you don't have a Google Colab account, since it has a Jupyter notebook over there and it's very easy, or you can even do it into some other ID. ID stands for the Integrated Development Environment. You can use some other ID as well. But the code that I'll be using for today's demonstration will be the Google Colab. If in case you want to learn side by side along with me, and why I choose the Google Colab. Yeah, so I'll let you know why I choose the Google Colab for this particular purpose. So what happens is that the Google Colab had one particular thing that it says that it helps us to define a Jupyter notebook, and also if in case my data set is very huge, right, and my machine is not having a capability of getting that particular data set loaded and applying an ML technique onto that, and then my machine is just having a CPU based processing. So what I can do is, when I shift on to the Colab, the Google Colab gives me a capability. It's basically a kind of cloud service. So it says that I'll be giving you some certain units that you can consume for free for the GPU based thing. If you want to go beyond that certain limit, you can buy the credits and you can do something as pay as per you go. You can use that cloud functionality. For example, your data set is very, very large in terms of volume, right? And if in case it's very, very large and your machine is not compatible, your RAM is low, you can change the RAM over there, right? So into the cool app. So you can change the RAM, you can change the processor, you can shift on that, okay, if I run this experiment, and basically this is what is being required when we are writing a paper. If we submit it to some certain good journal, for example, a journal of supercomputing or journal of big data analytics or related to big data, right? What it usually expects is, okay, what will happen if I run the same thing onto a GPU and a TPU? If my data set is being considered as a big, by big I do not mean in terms of volume only, it means in terms of volume, velocity, veracity, and the existing algorithms are not sufficient enough to be applied to that particular data set. So then I will call that particular data set as a big data. So in that particular terms, it says that, okay, you can use the Google Colab key functionality and you can have a variation of CPU versus GPU versus TPU. So I'll be telling you that as well, demonstrate during the demonstration, that, okay, this is how you can change the runtime environment from a CPU, making move towards a GPU and making move towards a TPU. So sometimes if my data is not large enough and I say, okay, use a processor as a TPU, my time for that particular algorithm will not be coming good because the TPU processing was not being required, and I'm giving that particular thing to a TPU, right? So that is why we usually do it for CPU. If the data is very huge, then we go along with and we show comparison of the CPU versus the GPU capability. Okay, so with this one, I would like to end up this for the theoretical part. I'm open to questions and I'll continue with the further steps for the lab into the next session, right? So I'll define all these steps and will show you the code and you can write along with me these particular codes. Yeah, one thing I would like to say into this particular lecture itself, so those who are looking for the particular research, right? For example, I just have picked up an example of a machine learning in healthcare for this particular case scenario, and this was a very recent and a good paper, and it was a survey paper, so I was just going through it and I thought of sharing this particular paper to you as well, since it was a computer survey paper and it was related to machine learning for healthcare, and under the healthcare also for one specific problem for infectious disease risk prediction, right? So for infectious disease risk prediction, they classified it under the two things. One was related to a pandemic and epidemic phases, and another was related to the endemic and elimination phases. So under the pandemic and epidemic phases, then a survey is further being conducted based on being classified as the special temporal dependency mining, the epidemiological parameterization, the epidemiological embedded learning, and enhancement of then under this one they classified it as the enhancement of data and information completeness and knowledge transfer between the similar disease patterns. So under the pandemic and epidemic phases, various papers that are specifically working on to these three things are being specified and being elaborated into a very beautiful manner into this particular paper. And the papers, if somebody is working on to an endemic and elimination phases, then the localized transmission patterns and the specific challenges into the disease elimination are being referred into this particular thing. So this was just an overview related to these phases, and that is why I've put a reference, and those who are working into the machine learning into a healthcare, or those who want to define there may be some PhD scholars, those who might be attending the particular this FTP and would like to categorize or would like to find out a problem. So this is a good survey paper from where you can learn about this one. So this is the paper and it's a recent paper. So that is why this is the one that I was talking about. The Liu and all are Liu only, but then the first name is different. And machine learning for infectious disease risk prediction. So whenever we are going to start our research for the PhD scholars, the first thing is to read and start with an ACM computing survey paper. or any other review paper, maybe from an IEEE journal or an ASIN journal, is usually being recommended. Since the author usually have referred minimum of 150 to 250 papers, and then might have wrote this survey paper. So you'll get a glance despite of first reading, starting with 150 papers of reading or 200 that you might be learning during your PhD, right? If you write your references and bibliography, it may come to 150 or 200. But to start a PhD with, you need to identify your problem, and you need to read a good recent survey paper. Okay, so that is one of the recommendations that I usually use for my learning purpose, and I would advise it for others as well. And then I refer to my acknowledgements to the Eureka lecture on logistic regression using the Python, and I used a book by Andrew Ng, and then I used a book by Aurelian Giron, Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. And also the dataset has been picked up from the Kaggle. But the same kind of steps, you can perform it on a Titanic data analysis as well. Okay, so with this, I would like to end up. Thank you.
Thank you, ma'am. Thank you for this insightful lecture. Now, I request to participants, if you have any doubt related to this logistic regression or some other related topic, if you have any doubt, because so far that we have covered 7 days, this different sessions. So supervised, unsupervised, linear classification regression problems. So any of you have some doubt, then you please ask. Ma'am, there is a one doubt. Uh, I hope you can see the chat box. Ma'am, you are on the mute, ma'am.
Yeah. So your
Yes.
question relates to that, what's the major difference between the logistic regression and the CNN, and how you decide? Okay. So I hope Dr. Sirin, they might have learned about the deep learning algorithms as well.
Not yet, ma'am.
Is
Deep learning
not yet?
means here this complete course is based on the machine learning.
Okay,
So
okay, okay.
machine
Okay,
learning means
so
yes.
okay, I'll tell them. Okay, so Sushma, what we consider usually, I'll give you an overview. If I consider, it's simply the bigger umbrella is usually referred to as an artificial intelligence. Okay, the very bigger umbrella. If you consider of a Venn diagram, if you consider a very big umbrella, you consider it as the artificial intelligence as the broader term. Then you have a certain term under that particular umbrella. Apart from the other terms, one is called as an ML, right? And under the ML, you have one some certain thing that is called as a DL, and DL stands here for the deep learning. And what's the difference is that deep learning is something that in our brain we usually have the neurons, right? And the neurons usually work on to the neurons usually work, and the for example, a small kid learns by seeing what is happening, and the neurons are being trained, and our mind is usually working. So the deep learning is something very similar to, right, the technique called as that usually works on this one. So what usually happens is, I'm looking for a diagram so that I had it in one of my, I was looking for so that I can show you that particular Venn diagram, but I hope you understand from the bigger umbrella. So the CNN is usually a technique which comes under the deep learning thing, and that usually takes the help of the neural network to train to this particular thing. Whereas the logistic regression, we do not consider it under the deep learning kind of a thing. We can simply consider it as a under the outer cover as well. Okay. So that's basically when you try to differentiate between the deep learning and the machine learning. So then you'll be able to understand the main difference between the CNNs, right? So basically, usually we do it for when we have a very big image data set, we usually used to apply a CNN kind of scenarios, or we have a videos, right? So in videos, we have different frames. So we usually used to see the neurons and how the neurons are being connected. And there are many interconnected layer, and there is a architectural layer difference between the CNNs. So whereas the logistic regression, okay, what is okay, so the next question is by Jyoti, that what is computational intelligence? Can you please throw some light on further bifurcation of it? Okay. Okay, so computational intelligence. So since I started with a bigger umbrella of an artificial intelligence, right? So making computers to interact and respond as intelligently as the human is referred to as a computational intelligence, right? And the machine learning varies with the computational intelligences, that we are trying to mimic the machine to behave like a human. We are trying to mimic the machine to behave like a human. And a computational intelligence, in my understanding, you can consider it as a broader thing under which you can use a ML. Then, okay, why do we use the sigmoid function into the logistic regression? Okay, so the sigmoid function, okay. Why? Okay, when I started with y is equal to mx plus c, right? So the logistic regression says that since I'm defining a probability, so I'll use the equation of the the linear regression one, and then I'll try to calculate the probability in order to classify them either as 0 or 1, right? And since the variable was continuous into the linear one, and the variable is categorical into this one, so it has to be mapped under a curve. So I cannot use the linear one because I changed from the continuous variable towards the categorical variable. But I use the same equation where I defined the probability as the sigma of z is equal to 1 divided by 1 plus e ki power minus z, where the probability was the sigma z. And then I substituted z by the y. So here z was y, right? So that is why, since I want to move it from this one, so I can map it only under the curve belonging to above the threshold and belonging to below the threshold. But there into the linear one, I was having a linear kind of a thing around the straight line. So that is why, since we shifted from the linear towards the logistic, we use the sigma function. Okay, so then I'll be joining you into the next session. Okay, so please be there after the lunch along with me. Thank you so much. Thank you so much to the coordinators.
Thank you, ma'am. So next session, should we start, ma'am, at 2 o'clock sharp?
Yeah, sure.
Okay.
Okay. Thank you so much.
Thank you, ma'am.
Okay.